At this time, I'm going to open it up to the floor. If you have questions for the panelists, they can be generic enough and we can decide who would like to field it, or you feel very specific if you have a very specific company question. Are there any questions?
Allison, I'm interested in the work that you're doing. My question is, how much focus do you have now on long-term repetitive injuries, and how much focus do you see going into the future work to take a look at not things that would impact the worker over the course of a shift, but maybe over the course of a month
or the lifetime of the worker. So the question is, in particular for our ergonomic focus in the digital humanities, how much do we evaluate it for its cumulative effect and the long-term effect? So due to the limitation of the tools, we have had to kind of take a safety approach of putting a safety factor in. We've done some research that shows that if you could evaluate it as a static posture, and someone could do it at their max, you can get a limit. And then if we apply 65% of their max, we feel that that is, we have some data that suggests that that could be something that can be sustained over an 8-hour period or throughout a 40-hour work week. So we use the digital human model to determine a maximum that someone could generate in that static posture, and then apply the 65% rule to each joint. When you get down into some of the allocations, like how many connectors, so each connector might be, well, all of our connectors are under 75 newtons. When I say connector, an electrical connector. So they're all under 75 newtons, and then we'll put some limits at the industrial engineering level that say no more than 3 connectors can be applied to one work, or to one operator. So although we have some research backing up kind of where those numbers came from, they're not very specific analyses that are in the digital human model right now. And that is one of the areas that we're very interested in pursuing, is this fatigue. And also I can answer you about that electrical connector, but what if you do the electrical connector, a hose, and then a trim piece? How do I add those up? The tools are not out there right now, so that is where we're looking at hopefully some of the tools that get integrated into the model would help us address. And I think GM is of a similar kind of focus to that. You're doing very static right now, safety factors applied, and then
we have a tool that we've been using just internal to try to identify over the course of the operation what the risk factors are going to be. And just like Allison says, we've got a kind of a numerical nomenclature to say, okay, this should be good. You know, and that can vary from operation to operation.
any other questions?
So the person from Toyota, what are some of the things that you're trying to do to, push this field? You say you get some resistance. I could just go in and do it myself. Why do I need a model? What are some of the things you're trying to do to convince people, yes, you do need a model?
Well, we're actually showing up with a presentation and showing videos of what we've done, what we can do. And that really turns on a light bulb. They didn't know that we existed inside of Toyota. So they are doing their own pilot programs with the new processes. A lot of stuff is already existing, so they don't need a simulation done on it. Anything new? And I think maybe continuing on with your question before was, we have a manual tool also, using observation and a manual tool to do, it's a predictor. It's not really going to tell you whether this is a bad process or a bad element. It's just a prediction. Is it red, bad for a shoulder, for a wrist, or whatever the case may be. But again, one of the challenges is measuring the value of it. So even though it's a good process, using simulation or manual observation with the tools that we have, It's like, so the injury was reported at this process, but did it occur, because we rotate every couple of hours to alleviate the burden so there's no repetitive, or limit the repetitive. So did the injury occur 6 hours before using this, and just so because I'm doing this now, oh, my shoulder all of a sudden hurts. Well, maybe the process a couple before is where it came from. Maybe they got injured playing basketball over the weekend, and this is where they reported the injury. So quantifying it, reporting it, getting accurate information is extremely difficult. But you got to start someplace. So that's one of the challenges, is how do we predict truly that this is going to be an injury?
Any other questions?
I was wondering if any or maybe a few of the panelists could give an example of a process that you feel is a really major change that you made in your engineering process because of feedback that you got from the software packages that you work with and work you've done.
Can you repeat the question?
Yes, I can repeat the question. He was wondering if any of the panelists could elaborate on a case study of use of the digital human model that really amplified the use of it.
That really resulted in a major change to your operation that was beneficial.
Right.
Yeah, we on one of the slides there that I showed, and it was where they were wearing their hoods and stuff. We actually went in and did that early enough that they actually went back and changed the product design because of the routings that were there. I mean, it just couldn't be accessed very well. So that was, we want to get more and more proactive in the process. And it's always hard to do it, but those are nuggets whenever you get it and you get value out of it, that we want to kind of use those as our glowing cases of this is what we were able to do, how we were able to improve a work cell. It was actually a complete work cell that we were evaluating. So we were able to get in early enough and get a better routing process that was in place in that work cell. So we've had, you look for those nuggets, right? I mean, that's what we're trying to do, because whenever you can do that, then you start kind of trying to spread the word of how to go about it.
I'm going to say we're probably balancing anywhere from 25 to 30 different new programs right now. And just as Craig said, at least once a week, we're implementing product changes just because of this work we're doing. So it certainly pays for itself as you talk about cost savings. I mean, one of the things we did to try to get some anecdotal data was we looked at a new program, 2 or 3 new programs we put in, and then we went into the plant after the programs were in and up and running for 6 months and then a year to look at their injury illness. And those related to ergonomics, and every one of them were significantly lower than the old products running in the plant. So that tells you that all of the work has paid off and they're doing the right thing too. So yeah, there's a lot of ways around it.
And at Ford, one of the ones that I think the use of the digital human model was really key was we were asked strategically whether or not when the GPS antenna came out, styling wanted it dead center in the middle of the vehicle because that looked the best. If you see the vehicle coming at you, you don't want this antenna off to the side. So we were able to virtually bring in all of our product line. So, a Fiesta, a Focus, which is really small, up to the F-150, and, and then by having that in the lab and using the digital human model, we were able to show what populations would or would not be able to reach that installation, and also, or reach it, and then also give them design direction. So in the end, we said, for some of the larger vehicles like the Explorer, you'll notice that the antenna is at the end of the vehicle, so it's not in the dead center. We said, can you get it to the end? Because we can get the operator in between, and then they can reach up and put it in. So that was one of the design directions and of the strategy on the roof, but to the end of the vehicle. And then the other part that was one of the strategics was it had to be a one-hand installation. So typically an antenna would have a little wire dangling, and you would feed it through the hole in the sheet metal and then make the connection underneath or inside the vehicle, and then you put the headliner up above it. So So with that strategy, we said that's going to be really hard. If it's in the middle, we're going to be leaning out. We showed it with all of our digital human models, a lot of the variety, and they were able to make it a one hand where the connection we secure underneath, like a cup, and then you take the antenna and you go and pop it in. So it's a one hand electrical connection because it does a positive feed into this cup. So we were really excited about that one as a strategy. So all Ford antennas now, when you see it driving down the street, you're like, I know. So I think it's very powerful like that for a strategy, not only the case studies, which to Gwen's point we're using every day, but it was nice to be able to show it strategically. This is the way we need to go. We have a few more minutes. Any other questions? Yep.
Follow up on that. Do you ever have any metrics or return on investment analyses you do for your modeling simulation value?
Any return on investments? Anyone want to take that?
That's what I was trying to say, is that it's difficult to measure. So if our tools say that the right hand is overburdened, is that actually going to happen? If the injury was reported using the tool for 8 shots, did that really cause it, or did the guy, again, playing basketball over the weekend, tweak his wrist? And that's just when he reported it. So measuring it is extremely difficult, and that's one of the challenges.
I understand it's difficult, but it is done in many instances. For example, back in the world, if you look at the addition of the third brake light on vehicles was something that was recommended from manufacturers folks, and there's a consequence for minimizing the amount of car accidents. So they can hold that up and say, look, we've reduced the number of accidents by X percent, say X dollars. When you can do those kinds of things, it really adds value, or you can demonstrate the value of your approach to your stakeholders, to your company. That's what I'm wondering if you guys had any of those.
Yeah, at Ford we got away from the injury one only because it is very difficult, and also there are a lot of other people who are doing a lot of other things that would influence that. Medical management, each plant influences a lot of the injury. So we have done a return on investment about issues, engineering issues, twofold. One, just the churn in our product parts. If you find a issue late. A late issue for us means you've already cut a prototype. So before we got into the virtual assessments, we were seeing about 300 ergonomic issues on a physical build. Hard to install parts, access, all those kind of things. And they would be written up as a specific issue. We are down to now less than 30, and we actually have it as an engineering metric that we're doing a 10% improvement year over year. So I think I'm actually target of 27 per program this year. So, and last year we achieved the target of less than 30. So that is a huge decrease in the amount of churn that we're seeing and the amount of issues that we're having to deal with. We did try and put a little bit of a price tag on an issue. Very hard to do, but we did estimate some issues can cost in the hundreds of thousands of dollars of engineering change, and others can be just a facility and tooling, which would be a couple $1,000s. We estimated that per change is about a $45,000 cost to the company if you find that issue late. So you've already cut steel, your designs have been frozen. So this reduction then from 300 that we used to see back in 2005 down to our 28 is quite a significant savings in engineering cost changes. Again, I believe there's tons of benefit to the injury side of it. It has just been a very difficult one to quantify.
And that's the same in TAM. I mean, several years ago we adopted a strategy that safety was important, but we didn't have to quantify, we just needed to fix it. And so for a number of years now, we've kind of led the automotive industry and injury illness, so we don't. But what we've done, as Allison said, is teamed up with the component owners for like our interior group, and they're working on their issues. You have so many issues that you want to try to bake out across the globe on a strategy basis. And most often, what we've been able to do is identify the ergo concerns in all of those components, and they're baked in as the product organization is looking at their strategies. So it's same difference, just a little different slant, and just identifying the issues early. And the way we quantify it is no ergonomic issues by the time we get to a saleable vehicles. And good news story. I know a lot of people in my club on the Volt. The Volt launched several months early, and all of the ergonomic issues have been identified and resolved.
All right, I probably have time for one more question.
I had a question on the software packages that most of you seem to be using. Myself, I'm in the crash safety industry, and we also work with 5th and 50th, 95th size occupants. But you probably aware these are hypothetical, theoretical anthropometry. They not necessarily represent the average population. The reason we work with these sizes, as I mentioned, is because the federal government tells us to do so. But in your industry, do you see any limitations to working with software that represents the human as an ideal human versus the actual size and height and weight of the operators?
Okay, so the question is, do we see any issues with working with the 5th, 50th,